So let's look at a very simple sort of series of steps that we can take to write our relational algebra or our SQL, sort of relational algebra for dummies or SQL for dummies. So let's start with relational algebra, and really most of the queries that we're looking at here are going to be talking about selection, projection and Cartesian product. And ultimately probably 80 to 90% of the queries that you write are going to involve those. Lots and lots of the queries that we look at in real life and look at on this course can just be done using selection, projection and Cartesian product with some functions. A projection obviously gives us the ability to choose particular columns, selection, choose particular rows, and then Cartesian product is being used to combine relations, tables together. And of course what we do is we combine the selection and the Cartesian product to give us that join operation. So here are 4 steps that we can follow. Identify the relations, the tables that we need to actually do the work. Add selections in to make sure that our Cartesian product becomes a join. Think about, are there other selections required for this query to be able to add it in so it can do its work? And then, what particular projections, what particular columns are we interested in as opposed to particular rows? I think the easiest approach here is just to do an actual example. So let's have a look at this one here. It says, show the name, job, sal and location for all staff with a salary greater than 25,000. So I'm just going to go through the 4 steps with that query and see how we apply them. So let's start off with identify the relations required and Cartesian product them together. Now looking at this query, it says show the name, job and location for all staff with a salary greater than 25,000. So we'd go back to the tables and we go, okay, which particular tables do we need to do this? And we can identify that the tables required are emp and department. And so we Cartesian product those together, and whether we do that is we write them down and then we'd put a little cross, just like that. That means we've Cartesian product them together. Now here we've just got 2 tables, of course. If you were using, you could have 3 tables or 4 tables or even 5 tables. And all you do is you write them down in a list like that and you just put a cross between them. So emp cross department, cross grade, for example, if it was one of the other queries involving the other tables that we've got. But here we just need these 2 tables. So that's the first step, step 1. Step 2, add appropriate selections to make the Cartesian product into an appropriate join. Now, what that will do is, as we know, it will combine every row from the first table with every row from the second table. So we'll end up with lots and lots of rows and some of them will be mismatched. So what we need to do is we really need to do a join rather than a Cartesian product. So the way we overcome that is by adding a selection onto the front. We add a selection with a condition, with a predicate. And with these 2 tables, emp and department, we look for that shared column. And we know that there's a department number in both columns. It's a foreign key and a primary key. So we can go combine these 2 tables together, these 2 relations together, along with this predicate. In other words, where department number from the first table matches department number from the second table, from the first relation and the second relation. Step 3, add any other selections required for the query. Now, if we go back to the query, and there's a little bit here that basically says with a salary greater than 25,000. So what we need to do is we need to add on another selection just so we keep those particular rows. And we could do that like that. We could actually add another selection on the outside. So you can see we've got an inner selection, only keep the rows where the department numbers are the same. Then we've got that sort of little bit of an outer selection there which says only keep the rows where the salary is greater than 25,000. We could write that in an alternative way. We could write it down like that. We could use an and. That would be absolutely fine. And then step 4 says add appropriate projections to get the required attributes for this query. So what we're really looking at is, we've got particular rows, which particular columns do we need? Well, again, let's go back to the original query and it says show the name, job and location. So we need to add on an appropriate projections to make that work. In other words, which particular columns we're interested in. So we can do that. So it looks like that just on the outside. And there we are. We've got our Cartesian product. Step 1, put the tables together. Step 2, put the tables together correctly. In other words, do it as an inner join. Step 3, add on any other selections that are required. Step 4, add on the particular columns that are required. Now, it's important that when you follow those steps, you do them in that sequence. Do the Cartesian product, turn it into a join, do the selection and then the projection. It is important to do the projections. It is important to do the selections before the projections and not the other way round. Have a look at this. So if you start from the right hand side, you can see we've combined the tables together and we turn that Cartesian product into a inner join. But then we've done projections next. So that means that we've removed all the columns apart from ename, job and location. And then we have a selection on the outside which says show me rows where only the sal is greater than 25,000. Now that logically will produce an empty set, and I'll leave you to think about why that actually doesn't work. There is a problem there.